Hello, and welcome to the final video of the P2 chapter Sequences and Series. On the screen is another exam question to start us off. This is reviewing recurrence relations. Pause the video now if you've got time to do this, and I'm going to go through the answers now. So we've got a sequence of numbers, u1, u2, u3, and that satisfy this recurrence relation. So the next one is equal to 2 times the current 1 minus 6, where n starts at 1 and gets bigger. Given that u1 is equal to 2, find the value of u3. Okay, if we know u1 is 2, and from the relationship we know that u2, the next one, is 2 times u1 minus 6, then it is 2 times 2, which is 4, minus 6, gives us minus 2. u3 we can find then from the relation 2u2 minus 6. u2 we've just found is minus 2, so that's minus 4, minus 6 is minus 10. So u3 is minus 10. Second part of the question is evaluate the sum from 1 to 4, so the first 4 terms of ui. Now, we've got the first 3 terms already, and because this is a recurrence relation that is not arithmetic or geometric, the sum formulas are not going to help us. That's why this number is so low, because what we're going to need to do here is just work out each of the terms and then add them together. So I need to work out u4, which I can do from u3. And then simply add them all together. The first 4 terms of the sequence. And that will give me minus 36. And there we go. As a quick review then, we've done arithmetic, geometric, sequences and series, sum to infinity for convergent geometric series, sigma notation to make it easier to write these questions, define and use recurrence relations. Finally, in this video, we're just going to talk about solving problems by modeling them as a series. So we're using everything we've done so far to solve word problems. Just a few notes. Sequences are great for modeling real-life situations. If you go into higher level mathematics, you'll use modeling a lot, and sequences are one of the ways that we can do this. The problem with this in terms of an A-level exam is that they tend to be very wordy questions, and you need to be able to understand the English. Now, if English is your first language, then you've got a bit of a head start. If it's not your first language, I would recommend you underline keywords, or perhaps you do a few different questions and look at the same language that comes up in all of the different questions and get a feel for the sorts of language that is used in these questions. When you can get through the language, you should use the information to write out the terms of the sequence. So be clear what your sequence is, what your starting term is, whether it's arithmetic or geometric. And once you've confirmed if it's arithmetic, you want A, N, and D. And if you've confirmed it's geometric, then you want A, N, and R. And then go ahead and use all of the stuff we've talked about in the previous videos to get the answer to the question that is being asked. So the rest of the video is just going through 2 examples. And you can see straight away, compared to our previous questions, especially the one at the beginning of this video, this is a lot of language. So I'm going to walk through it. Ahmed starts a new company. Okay, that's a nice bit of context, but it's not really telling us anything mathematical. in year 1, his profits will be 20,000. That's an outright statement. So let me write that down. In year 1, his profits will be 20,000. He predicts his profits to increase by 5,000 each year, so that his profits in year 2 are modeled to be 25,000. In year 3, his profits are going to be 30,000, and you can see that we've got an arithmetic sequence here, where A is 20,000, and the common difference we're adding 5,000 each time. But we haven't finished yet. That's up to here. He predicts this will continue until he reaches annual profits of 100,000. So this is going to keep going until he gets to 100,000, and we don't know what year that is yet. But when that happens, he then models his annual profits to remain at 100,000. So at this point, the sequence stops, and it doesn't add 5,000 each time. It just continues 100,000, the next year 100,000, the next year 100,000, and so on. And the question is, calculate the profits for Ahmed's business in the first 20 years. So immediately, my question needs to be, is this number here bigger or smaller than 20? If this number is bigger than 20, I don't need to worry about this maximum. I can just use this sequence information with n equals 20. But if it hits this point before 20 years, then I need to stop here with my sequence and then just start adding 100,000s for every year after that until I get to 20. So my first question is, what is this number? And our nth term here needs to equal 100,000. So my general term, u of n, is equal to a plus n minus 1d. My question is, when does that equal 100,000? And I know a is 20,000. N is the thing I want to know. D is 5,000. And I just solve my equation. So 100,000 minus 20,000 is 80,000. 80,000 divided by 5,000 is 80 over 5 is 16. I should have done all of that on the calculator just in case, but I'm pretty sure that's right. N is 17. So from n equals 1 to n equals 17, I can use this arithmetic sequence. I can find the sum of this up to this point. But for year 18, 19, and 20, I just need to add 100,000 for each of those 3 years. So I need to split this into 2 parts. So let's find the sum of the first 17 years of this sequence. And that will be 17 over 2. 2 times a, which is 20,000, plus n minus 1, 17 minus 1 is 16, times d, which is 5,000. And if I put all of that on my calculator, I get the answer 1,020,000. But that's not the total profits up to 20 years, that's up to 17 years. And when we hit this point, we just add 100,000 for each remaining year. So the profits, 20 years, is equal to 1,020,000 for the first 17, plus 18, 19, 20, so there's 3 more years, and each of those has 100,000 each. So that's 300,000, so that's 1,320,000 which sounds like a lot of money to be making profits in a business. But remember, that's over 20 years. Oh, that's still pretty good, but, but it's not quite as amazing as it sounds when you say 1,320,000. So that is the answer for part A. Part B is a 1-mark question. State one reason why this may not be a suitable model. And there will be some flexibility. If this is an exam question, there'll be a few different answers, and as long as you say something sensible and true and related to the question, you should be okay. So this model that he's got is a little bit overly simplistic. To increase your profits by the same amount each year is unlikely. 5,000 each year increase. It doesn't really show any good years or bad years. So what would I say here? It is too simplistic to expect the same $5,000 increase each year. And if you had time to elaborate on that to make sure you got the mark, you could say something like, maybe one year he would have a bad year, and it would be less than this. Part 3. Ahmed's financial advisor says the yearly profits are likely to increase by 5% per annum. Using this model, calculate the profits for Ahmed's business in the first 20 years. Okay, this is important to realize. Obviously, this is still true. This is still the context. And this is still true. This is still year 1. But the prediction, his model from here, all the way down to here, this is now gone. That was part A. But the prediction he's used has been superseded by financial advisor. So we're using this new model down here. But year 1 is still going to be 20,000. So the first term in our sequence is still 20,000. The profits, this thing, are likely to increase by 5%. Okay, 20,000 increased by 5% is 21,000. So with this new model, the second term of the sequence is 21,000. And if I increase that by 5% again, I get 22,050. And if I increase that by 5%, I get 23,152.5. And our sequence is going to get more and more decimal based. But I don't need more than that, because I've got enough to recognize that this is a geometric sequence. What I did on my calculator to get this was to multiply by 1.05, and I did the same thing here. I've got a geometric sequence where A is 20,000 and the common ratio is 1.05. Okay, just going back to the idea that this is a finished model, because we need to remember here that the $100,000 cap was part of Ahmed's model. That does not apply to this model. There's no maximum given by the financial advisor. So I don't need to worry about 100,000 maximum. All I need to do is follow the sequence for 20 years. So I guess arguably you might say this is a slightly easier question, because we don't need to worry about cutting off the sequence at any point. As long as you can remember your sum for a geometric sequence, which is A, 20,000 times R to the power of n minus 1 divided by R minus 1. Put all of that onto your calculator. 1.05 to the power of 20 minus 1 divided by that is 661,319.0821. And because this is dollars, I'm going to cut that off to 2 decimal places. If the question gives you other instructions, like 3 significant figures or something, fine. But if it doesn't, money should usually be to 2 decimal places. And it's interesting to note that this is almost half the amount of profits that Ahmed's more simple model predicted. So that's our first example finished. The second one is an old exam question. The resident population of a city is 130,000 at the end of year 1. A model predicts that the resident population of the city will increase by 2% each year, with the populations at the end of each year forming a geometric sequence. So the first term is at the end of the first year, 130,000. And it is important to note that the entire population will be the term. So I will not expect to be adding these together. I don't expect a sum in this question, because if we did that, we'd be adding the same people over and over again. So it's the terms that we're probably going to be interested in. Part A. Show that the predicted resident population at the end of year 2 is 132,600. Okay, that is very easy, 1-mark question. We start with 130,000 and it's going to increase by 2%. And that should give us the second term, and I'm just going to check on my calculator that that agrees with the number they've given us, 132,600, yes. So our sequence, 130,000, 132,600, and so on. And again, let me reiterate here, the term is how many people there are. I don't need to add these together because I'd be adding the same people twice for most of it. So this is the total population at the end of year 2. Write down the value of the common ratio of the geometric sequence. Well, that's quite easy as well, another 1-mark question. The ratio is what I multiply by. R is equal to 1.02. Okay, now we've got A is 130,000 and R is 1.02. The bulk of the question, 4 marks, comes in part C. The model predicts that year capital N will be the first year which will end with the resident population of the city bigger than, exceeding 260,000. Show that this is true. Okay, they're giving you this probably so that we can do the next part of the question, even if we can't do this one. Don't start with this. We need to finish with this. So think about what we're doing. Year N is the first one that's bigger than 260,000. We're looking at the term. So we know the general term of a geometric sequence is AR to the n minus 1. So when little n equals capital N, this thing must be bigger than 260,000. So A times R to the capital N minus 1 must be bigger than 260,000. And we know A and we know R, so we can put those in. A is 130,000 times 1.02 to the capital N minus 1, bigger than 260,000. The first thing I'm going to do is divide by 130,000, and they've given us very nice numbers here because this is half of this. So when I divide that through, I'll get a 2. Now, of course, I need to use my log rules. I take logs of both sides, and then I can bring the power down the front. So we've got n minus 1 times I would normally do natural logs, but in the question they've got log base 10. So I'll have to use log base 10 of 1.02 and log base 10 of 2. Now I can divide both sides, but I should just check on my calculator that log base 10 of 1.02, the thing I'm dividing by, is not negative, because if it's negative I've got to flip the sign. It's a very, very small number, but it is positive, so I don't need to change the sign. So we've got n minus 1 is greater than log base 10 of 2 divided by log base 10 of 1.02, and I'm almost there. Just put the 1 on the other side. And that my final step of my working should be the same as the thing they want, and it is. So our final part of the question, find the value of n, another 1 mark question. Basically put this on your calculator and figure out what it is. So if I put that, we've got log base 10 of 2 divided by log base 10 of 1.02, and then add 1, 36.0027 ... Now that's very, very close to 36, but this is a strict inequality. N needs to be bigger than this number, so n is equal to 37. And again, as I've said on previous videos, if you want to check this, if you've got time, put this number back in here with A and R and check that that does give you a number bigger than 260,000. And if you've got lots of time, put this down 1 to 36, put that in here and check that that number is less than 260,000. In this case, it will be just less than 260,000. And that is the end of our sequences and series chapter. If you've got the textbook, you can practice this sort of modeling question using exercise 5i, and you can practice all of this chapter with a mix of questions from the chapter 5 review exercise. And maybe I'll see you in another video series.